equipment examination of the friction lab. And it is lab 6. We're going to talk about static friction and kinetic friction. I think I explained a lot of it in the lecture, but in any event, we're going to have a block, we're going to have a force sensor, and what we're simply going to do is pull on this block with this force sensor. We'll pull like that. As you know, the force to pull the block is going to be maximum when the block is stationary. That's going to be the peak force. And once the block gets sliding, the force that we pull on it will be the average force or the moving force, kinetic force. We go through this procedure, and if you come over here, go to the screen, and we're going to see this type of graph. And as you can see, the peak of the graph is right in the shaded area. And it also goes to when the peak is the peak force, and then as it levels off a little bit, that'll be the average force. Now we've measured this block, and this block is about 0.3 kilograms. And as you can see from here, our peak force will be 1.3, and our average force is about 1 Newton. And that's in concert with the information that's in your table. Tables 2A and 2B, I believe. Knowing those factors, knowing the peak force and the average force, we can determine the coefficient of static friction and the coefficient of kinetic friction by, of course, knowing that U equals F over N. This is the examination part of the lab that talks about static and kinetic. There's a part 2 to the lab working with a motion detector that we're going to talk about in a moment, and that's just dealing with kinetic friction. When we did the first part of the lab, we used the force sensor to pull the block. We will be adding weights to the block. In the second part of the lab, what we're going to do is we're going to have a motion detector here, and we'll have a block, and what we'll do is we'll just slide the block towards the motion detector like that without hitting the motion detector. We'll do it with the block, and then we'll add various amounts of weights to the block. What we'll do again with our computer is to generate a V over T graph. This is lab 12B, V over T. If you look at the V over T graph, we'll highlight the last part of the graph. Right here, we'll hit on the linear function, and that'll give us the acceleration or the deceleration of the block as it's moving to the motion detector. Knowing that A, we can enter it in table 3A, we can work through the calculations, and we can determine the kinetic coefficient of friction for the block under all the different scenarios.
Okay.
Okay.